Hey guys, welcome back to Jyoti classes. And today we are going to learn about complex analysis, the continuation part of MMP, that is mathematical physics. So, in today's class, let's begin. First thing is complex analysis. In complex analysis, how to represent that? A complex analysis is represented as z is equal to x plus iota y. I is the imaginary function, where z bar is the complex conjugate of the any function, where z bar is equal to x minus iy. Okay, and the modulus of z is root of x square plus y square. If you want to represent this x and y in terms of polar form, then x is written as r cos theta and y is written as r sin theta, where z is equal to r e to the power of I theta and modulus of z is r. And to know that what is the argument of z, that is equal to theta and that is equal to tan inverse of y by x. This is the basic things you should know about complex analysis. Now in complex analysis, let's learn more about identities, type of identities. In that, if the modulus of z1 plus z2 is less than or equal to individual model of z1 plus z2, for z1 minus z2 it is greater than or equal to modulus of z1 minus of z2, and for z1 into z2 it is that is equal to z1 mod is equal into z2. z1 by z2 is individual of mod z1 by mod z2. Okay, these are the few of the identities that you should be aware of. And next, argument of z function, any complex function for z1 z2 so on up to is take the argument of the individual function, that argument of z1 plus argument of z2 and so on up to argument of zn. If the argument of z1 by z2, what will be the value? That is argument of z1 minus argument of z2. Okay, these are the things you should be knowing, and the basic expression that you should be aware of, those are: first, how can we represent a cos function or a trigonometric function in terms of exponential? That is, cos hyperbolic theta is e to the power of theta plus e to the power of minus theta by 2. Sin hyperbolic theta is equal to e to the power of theta minus e to the power of minus theta by 2. Okay. Next thing, cos theta is represented as, that is equal to e to the power of I theta plus e to the power of minus I theta, and sin theta is equal to e to the power of I theta minus of e to the power of minus I theta by 2i. Okay, see, in hyperbolic we did not take iota function, imaginary function is not considered here, and whereas in cos and sin function we take exponential term with imaginary function, that is e to the power of I theta and e to the power of minus I theta. Okay, these are the few basic expression, you should know that. And after that, coming back to De Moivre's theorem, that is cos of theta plus I into sin theta to the power of n is represented as cos of n theta plus I sin n theta. And next, if the function is represented as u of x comma y plus I v of xy, here u of x comma y is the real function of that given expression and iota v of x comma y is the imaginary function. Okay, you should be able to differentiate the real and the imaginary function for a given f of z. Okay. Next, with the help of Cauchy-Riemann equation, you will be able to find whether the given function is analytic or not. How to know that? For any given function f of z, if dou u by dou x and that is equal to dou v by dou y, that is, if you differentiate the real function with respect to x and the imaginary function with respect to y, if they are equal, this is our first condition. And the second condition is, that is partial differentiation of dou u by dou y, that is equal to minus of dou v by dou x, that when you partially differentiate real function with respect to y and imaginary function with respect to x with a negative sign, if you get that value, if it is satisfying both this condition 1 and the second equation, then your given function is analytic. Okay, you should be aware of, whenever you will see the question of to find the analytic for any given expression, you just need to check this condition number 1 and the condition number 2 to know whether the given function is analytic or not. Okay, next, moving on to the next part, that is, if it's given that it is a harmonic function, condition is mentioned there, and we need to find whether it is analytic. With the help of Laplace equation, we can do that. What is that? What you have to do is doubly partial differentiate, double partial differentiation of function u with respect to u, the real function only with respect to x and y, doubly partial differentiation, that is equal to 0, and similarly for the imaginary function is equal to 0, then you can be able to solve for any given harmonic functions solution. Okay, as I said before, Cauchy-Riemann equation for the Cartesian form of x comma y. In this, you can also use this Cauchy-Riemann equation for polar form, that is r theta. And how to find that? The value is dou u by dou r, real function with respect to r, and that is equal to 1 by r dou v by dou theta, imaginary function with respect to theta, and dou u by dou theta is equal to minus r dou v by dou. If you do r, this is what you have to do. If it satisfies this condition, then you can know whether the function is analytic or not. Okay, next, moving on to the next part, there is a trick to know that whether it is an analytic function or not. The trick is what you know. The first thing, if any question f of z is given, in this f of z, the value of this z is always a positive integer. Rather than solving that much, just focus on that the power of that f of z equation, z to the power is positive integer, then you can directly say that it is an analytic function. And the second part is the function of that, the z cannot have the power of negative or fractional or exponential. If any values are something like this, then you can directly say that it is not an analytic function. Just focus, if it is a positive power for the z, then go for that equation to know whether it is analytic or not. Directly you will get, but still you have to cross check it. You can do that rather than seeing all the equations. If any equation containing negative to the power of z and any fraction value or any exponential value, just leave those equations. Okay, next, you have to know in this what is isolated and what is non-isolated. Here isolated is for the given function 1 by z minus z2. Here I have just taken the example for isolated, where you can directly find the roots for the z value and where the denominator becomes 0 and the answer tend to infinity. Where you can find the roots for the given function is your isolated. And in non-isolated, when you get the roots infinite value, that it is not having any particular root. When it does not have any particular root, then it is non-isolated equation or a function, I can say. Okay, so you have to check whether it is an isolated or a non-isolated equation, that and all. If it is an isolated, then there are remaining two parts, and what are that is whether it is removable or non-essential or essential. If it is a removable, then sign of, like it will be in this form, sign of z by z, that is equal to 1 by z. Here removable I means that I can represent this function of z, sin z, in the equation form with the Taylor series or anything series, where you can expand that function. Okay, so that in the if I take this z inside, I can delete the z value. Okay, so any function removable, so that we can represent the any function into its like expansion form, and that is a removable function, and that is non-essential or pole. Here what is that, we can get the roots of the value and what is its order. And for the essential, where exponential are expanded, these are similar things. Okay, when you, these are very very simple things that you are already aware of, but while solving the questions related to these questions including these types, so I will be explaining you in detail. Just make a note of these concepts that you should be aware of. Okay, next, now coming back, so let's this much be for today's class. In the next class we will be focusing on this order 1 simple pole and order 2 pole and all. Okay, thank you.